this is Britt Caswell with another example video. In this video, I'm covering example 2 from section 5-4 in the SavvasRealize Algebra 1 textbook. So the goal of this video is to understand vertical translations of an absolute value function. Alright, so the example starts out, it says, how does adding a constant to the output affect the graph of f of x equals the absolute value of x? So now remember, when we're talking about an output, we're talking about the y value, essentially. So if we have some kind of function, and we add something at the end of it, doesn't it make sense that that value is higher? That the y value would just pop up here? And doesn't it make sense that if I were to subtract a value from there, or add a negative value, you would say, doesn't it make sense that that y value, the output number, would become less? So what that does to the graph is when you add something, it causes the graph to go up, and when you subtract something, it causes the graph to go down. So what I'm looking at, you guys might see this, or might have seen this in a previous video, where we have an equation that looks like this. What we're doing is we are analyzing this plus k. Okay? So if it says plus k, you're going to translate up. And if it says minus k, you're going to translate down. Now it's important to recognize that this is outside of the grouping symbol, and that's why it's going up and down. We are going to be looking at adding and subtracting things from the input, which is inside the grouping symbol, and that's going to make us go left and right. So don't get mixed up with this k being outside and the h on the inside. Okay? So you guys know that the absolute value graph is a V shape, right? So what I'm doing here in black is I'm graphing our parent function. Alright, this is f of x equals the absolute value of x. Alright, so now what I'm going to do is I'm going to graph the absolute value of x plus 3. So what this plus 3 does is it moves our graph up by 3. And every point on the graph is moved up by 3. So all that it did was it caused us to do a vertical translation up by 3. Now, moving the graph up and down, that didn't change the axis of symmetry, did it? So our axis of symmetry is still at x equals 0. Alright, it's still right here on the y-axis. Now understand, when we talk about an axis of symmetry, that is a line, so it must be an equation. That's why I say x equals 0 here, to talk about that vertical line. Okay. Now the vertex is this point here, which is at 0, 3. So it's worth noting that that k value, whatever it is the y value of the vertex. Kind of neat. So let's go ahead and let's check it out with this one. So I'm going to graph g of x here. So real quick, let me mark that was p of x equals the absolute value of x plus 3. That way, if you're looking at it later, you can see where it is on the graph. Alright, so now what I'm doing is I'm subtracting 2 from our output. So when adding makes us go up, subtracting shifts the graph down. And so each point that's on this parent function is now moved down by 2. And so you get a graph that looks like this. So this is g of x equals the absolute value of x minus 2. So our vertex, our point here, is at 0, -2. And so you can see where that minus 2 became the y value for my vertex. And our axis of symmetry is still at x equals 0. All right, it's still right here on the y-axis. But there we have it. So that is a vertical translation of the absolute value function and looking at the vertex and how the axis of symmetry is affected. Until next time.